Okay, here we're going to integrate secant cubed times tangent cubed. So we're trying to worry about powers of trig functions and how they interact and integrate. I think there may be quite a few different ways this one could be approached. I'm looking at it and I think one thing right now though. The secant cube, tangent cube, I'm going to try and take a secant and a tangent out of both of these. So I'm going to pull that to the side. So I'm going to write secant squared x times tangent squared x times secant x times tangent x dx. And what I'm thinking here, what my train of thought is that secant tangent is the derivative of secant. So I'm going to try rewriting tangent squared and see if I can put all this front part in terms of secant and make the secant tangent at the end be the derivative of it. So let's see here. So, ooh, got a new color. Let's don't use that. So let's try this. So we're going to have the integral of secant squared x and then tangent squared plus 1 equals secant squared. So this will be secant squared x minus 1, if I'm not mistaken. So let me think. Cosine. Yes, that's right. And so that'll be times secant x tangent x dx. So I can multiply this out now, but what I'm going to do is I'm going to use a u substitution. I'm going to let u equal the secant of x, and the derivative of u will be secant x tangent x dx. Okay, so in that case, I can replace what I have. I can bring this down as u squared times u squared minus 1 times du. So what I'm trying to integrate is u to the fourth minus u squared du. So that turns into 1/5 u to the fifth minus 1/3 u cubed plus c. But we need to take this back to our original x value, which the u was secant x. So it'll be 1/5 secant to the fifth of x minus 1/3 secant cubed of x plus c. Now, I don't think I've mentioned this before. I have said you can use different substitutions to get to an answer, to something you can integrate. If we had broken this apart and made a different substitution, we may get an answer that looks completely different than this. So it may be an answer that's all in terms of tangent. And you remember when we did secants and sines and cosines, I said if they're both odd, you could pick which one you wanted to use. So if you switch substitution you use, you may get a integral in a completely different function. That doesn't mean it's wrong. It just means that there's some identity to get it from one function to another, but it doesn't have to be taken to a certain function at all. And even if you can't balance them out, where it seems like they don't really work out, it's because the c at the end. So if they're just like a constant number off when you try and make some adjustments, it's probably because the c would be different in the two different scenarios. But anyway, if we had tried to replace the secants instead of the tangents, we may have gotten an answer in terms of tangents. All right, thank you.